Okay, so in your exercise classes, you are not really going to learn about those special classes. I'm pretty sure that you are not going to learn about sealed classes in your exercise class. You might learn about static classes, but I'm not sure. And I think you will probably learn about abstract classes at some point, but this is also kind of optional. Therefore, this slideshow of mine gives you explanation about this topic, which you cannot get in the exercise class probably. So please try to pay attention. Okay, let me raise this question at the beginning. Just imagine you implemented a class, a beautiful class. It's kind of perfect. And you don't want to let other programmers to further develop your class because your class is perfect. So this means you want to prohibit inheritance from your class. Can you do that? This is the question. Well, actually you could do that based on your current knowledge. You can also do that by some hacking. If in your class you implement only private constructors, then nobody can initialize this. There is a typo here, sorry. Nobody can instantiate your class. Let me share the slideshow again. Yeah, so this means basically no child classes can be implemented for your class because of the constructor chaining, which I was talking about last time. Exactly. So now we are going to learn about a new keyword in C#. This keyword is called sealed. Sealed means you put a seal stamp on your class. If you seal it, if you close your class, it means that nobody can inherit new classes, child classes from your class. So here is an example you know very well, the console class. You use the console class so many times. Actually, the console class is a sealed class originally, which makes sense, because this console class was implemented by Microsoft, and the Microsoft guys implemented this class in a how to say, in a final way. So this class is ready. It doesn't need any extension. This is what they think. I mean, at the Microsoft. So they seal this class, they close this class. Therefore, you or me or any programmer in the world cannot further develop this class. We cannot inherit child classes from this class because this class is final. It's sealed. There are even more important reasons why such classes are sealed. This reason is written at the bottom. The C# compiler can perform certain optimizations for to sealed classes. For example, to sealed classes, early binding can be applied all the time. I hope you remember, we learned about early binding and late binding. And late binding is always much more expensive regarding runtime. So for sealed classes, early binding can be used all the time. Okay, so classes can be sealed, but not only classes. you can also seal methods. Just look at the example. Here I use a circle class. Inside the circle class, I implement the area method, which is final. All circles need this formula, mathematical formula. So I seal this method. This means no one can override this method in the child classes of the circle class. Yeah, as I mentioned at the top, on the top, only virtual methods can be sealed. Okay, if methods can be sealed, then of course properties can be sealed. I just change my method to a property because in this case I can do this. So this is how you can seal a property. You need a virtual property in the parent class that you can override in the child class, and you can also seal it if you think it doesn't need any more or override in the child classes of the circle class. Okay, so I think this is it about sealed classes, sealed methods, and sealed properties. And I checked out what if other languages, other programming languages, provide similar constructs. I found out that Python doesn't have any sealed classes or methods or anything. C# and Java has something like that. Actually, they provide the same, but they use the final keyword instead of sealed. So everything is the same, for example, in Java, but you have to use the final keyword instead of the sealed keyword. That's all. And actually, I actually prefer this word final instead of sealed, because I think the word final represents the meaning much in a much more sophisticated way, because you know, if you seal something, it's final, it cannot be changed later on. Okay, just look at the image at the bottom or in the middle. This shows how the final keyword is used in Java for what purposes. And it's interesting that the final keyword is also used for constants. So in Java, there is no const keyword. You know, in C# there exists a const keyword. In Java, there is no dedicated keyword. They use the final keyword for constants as well. The rest in the picture is the same as in C#. Final method. You can have final methods, final classes. They mean the same. Of course, in Java you cannot have final properties because in Java there are no properties. But this is something you already know. Okay, this is about sealing classes. Do you have any question about sealed classes, methods, or properties? Any question? You can write it in the chat or use your microphone.
No, sir.
No?
No.
Ah, okay. Sabri is here. No question. Great. Then I would like to continue. So the next, as the title suggested, we also have to talk. We also have to learn about static classes and abstract classes. So this is what I'm going to start now. Yeah, by showing this slide here. Here. Okay, so by using both kind of classes, static classes and abstract classes, you can somehow disable instantiation. Actually, yeah. So this means you have a class and you cannot create instances of this class. This is very similar to what we learned about the static keyword. You know, static means something is class level. So if you have only class level stuff inside your class, then actually there is no point to create instances from this class. This means the class stands itself, no need for several instances. Okay, but we are going to learn about another keyword, abstract. This is a much more important concept and keyword in OOP, abstract. So you can mark classes as abstract classes, which means the class is not yet ready. So there are parts in this class which you cannot really implement yet. And since this abstract class is not yet ready, therefore there is no point to instantiate it. The instances cannot work because they are not ready yet. So this is the idea. First, let's learn about static classes. Okay, so you call a class static if only static fields, properties, and methods can be found inside the class, and no object level, non-static elements, not even a constructor. Last time we learned about a design pattern called Object Factory. Object Factory was part of the Kahoot quiz as well. So this was one of the OP design patterns. There are several such design patterns, and now I'm going to mention another design pattern, which is called Singleton. Singleton is a class from which you need only one instance only. Singleton. It stands alone. It's single. So you only need one instance, and this means you don't need instances, and therefore you don't need a constructor either. Let me just show you first a static class. So here, as you can see, inside this class, I use only two methods, both are static. If you have everything static inside the class, you can mark the class itself static here in the header of the class, static. This means, again, that the compiler does not generate a default constructor either, so nobody can instantiate this class. You can use this class only in this way. Just look at the green box. Class name dot method name. That's the only purpose of this class. I'm going to come back to this previous slide, but first let me explain this sentence on this slide. So you can see a typical use case for static classes, which is using so-called helper classes. You will find out later that in several scenarios, for example, in graphical user interfaces or when you implement web applications or mobile applications, you frequently need to implement helper classes. A helper class somehow collects useful methods which you can use anywhere in your program. So, for example, this is a helper class which collects all the methods for converting temperature values, for example, now from Celsius to Fahrenheit and vice versa, but you could extend this set of methods if you want. Anyway, this helper class collects all those methods, and again, as you can see in the green box, you can use those methods whenever you need them. And of course, you don't need to instantiate this class. You need only the class itself. This is why it is static. Okay, I think I over-explained the example. Of course, if you have any question, raise it. Meanwhile, back to the previous slide. So here I have a statement. If you have a static class, inheritance, so not only instantiation is disabled, but also inheritance. You cannot inherit child classes from this class. You cannot inherit child classes from this temperature converter class either. Why? Again, this is true because of constructor chaining. This means actually that the static keyword, if you put it in front of a class, is stronger than the sealed keyword. You see? I hope you see that. Meanwhile, I can see that in 7 minutes, Zoom will disconnect, but I will reconnect immediately. So I hope you won't notice any what? Interruption, thanks. I hope so. Okay, no questions so far, right? Okay, then let's see what is going on in other languages regarding static classes. Well, this is kind of interesting. Neither in C++, nor Java, nor Python, you can use static classes. So this is something very special in C#, that you can mark a class as static. In those languages, especially in C++ and Java, you can mark only methods and fields as static, but not the class itself. There is an exception in Java I'm mentioning here. This is a very minor, very special case. I don't want to go into details. If you are interested, just look this up. In Python, there are nothing like static. Actually, I was talking about static stuff in Python, which is kind of interesting, but classes cannot be static in Python either. Okay, so let me continue with a very special topic. I think in your practice class you won't touch this topic either. Therefore, I'm going to use Visual Studio in a minute and show you some example, some demo. And this, okay, this topic is about the so-called extension methods. Extension methods are also very unique. They can find them only in C#. You cannot find extension methods either in Java or C++ or in Python. This is very C#-like concept. Okay, so, and they are really nice. I'm telling you, extension methods are really pretty. I hope you will like them. Okay, let's see. So the idea of extension methods is extending existing classes with new methods. So I'm just imagine I already have a class. Let's suppose I didn't implement it. It's implemented inside the .NET framework, Okay, so it was implemented by Microsoft. And I would like to extend this class with a new method, somehow from outside. This is crazy. I mean, of course, you could do that by using inheritance, but now I'm not going to use inheritance. I'm not going to implement child classes, but I'm going to plug in some new method directly into the class. Okay, I'm going to show you an example in a minute, but at first, how can you do that in C#? You need a static class. I mean, you have to implement a static class. Inside the static class, you have to implement this method as a public static method. At this point, let me show you this example. So for example, here, I created a static class, as you see, and inside the static class, I implemented a public static method. I just gave a name to the method and the class. With red, I mark a very special syntax here. Before the first parameter, I use the this keyword. This is kind of special. What does it mean? Just look at this sentence here. So the first parameter specifies which type I want to extend. And this type should be preceded by this keyword this. So in the example, I use a string parameter. I put this keyword in front, and this is how I declare that I want to extend the string type. You know, string is a class inside the .NET framework. This is an existing class, of course. And I want to extend this string class with this isPalindrome method from outside. In the green box, you can see how I could use this method from now on. I'm using a string like kayak dot my method name, and that's it. I'm not using a parameter here because the single parameter marked with this keyword goes first. So the string goes first. Then I'm using the method name and no parameters left. Okay, I hope you understand what is going on. I extended the string class with a new method. So now Zoom will disconnect soon. So meanwhile, I'm going to my Visual Studio, and I will show how this code executes in live. So let's continue. I think I shared. Can you see Visual Studio now?
Yeah, we can see.
Great. Okay, I just copied the code from my slide here. So this is the static class inside this public static method and this keyword in front of the parameter. And let me show you how this works. So do you know what a palindrome means? Palindrome in English? Yes, no? Kayak is a palindrome. Do you have any idea why kayak is a palindrome? Guys?
No, sir.
No. Okay, palindrome is a word which you can...
Because we can read it from both sides.
That's it, thank you. You can read it from both sides, from left to right or right to left. You get the same. Meanwhile, if you have any good idea for a palindrome, a better idea than kayak, just share this word with me, okay? And I'm going to use it. Okay, so the main message here, I have a string here. This is a string instance. And as a string instance, it has methods, lots of methods coming from the .NET framework. But it's important that my method is there, the isPalindrome method. If I comment out my method, then I cannot find this method anymore in the list. So as you can see, I really extended the string class with a new method. This is crazy. There it is. Okay, let's, well, this method tells you if the string is a palindrome or it is not, so I can check it out with an if statement. Otherwise, let's just write this on the screen. Sorry, I'm going to share my whole screen instead. Okay. So if I execute, okay, can you see the result, the console?
Yes.
Okay. So this is a palindrome. Of course, if I give not a palindrome by, for example, kayaks, I don't know if it is a real word in English, then it's recognized.
Can give dead.
Excuse me?
Can give dead as a palindrome.
Yes. So can you give me another palindrome, a nicer one?
Dead.
Dead? You mean this?
No, it's like the father, you know, D-E-D.
Yeah. Okay, I see. Of course. Yeah, this is a palindrome, of course. But if I use dead, like Walking Dead, then this is not a palindrome. Okay. So just feel the magic. I plugged my method inside an existing class, the string class. I extended it. This is real magic, what's going on here. I hope you liked it. Okay, then you don't give me any sign of joy or something. Let me show you another example. So actually, you can extend any type you want. If you check out this example, can you tell me what type I'm extending here? So, any idea what type I'm extending here? Tell me. Guys?
Type of list.
Yeah, exactly. The list.
Yes.
The list class, you know, list is also a class.
Yes.
But you are only partly right. I'm extending only lists with persons, exactly. So if you would try the same, so if this is how you can use this method, you can see at the bottom. If you have a list of persons, you can call this oldest person method. But if you have a list with something else with integers or strings or doubles, you cannot access this method, which is, you know, logical. Why would I use the oldest person method on integers, for example? Yeah, I'm not going to try this piece of code now. You try it yourself, okay? This is a homework for you. Okay. Let me show you something in Visual Studio instead. So actually, I think you will like this as well. If you have a list, you could check out all the methods inside this list. And you can see the list class provides a lot of methods, lots of methods, plenty of methods. But actually, this is not true. I'm going to comment out this using here. Here I'm importing a namespace. If I do this and check out the list for the class, for the list of the methods for the of this class, you will see that now they are much less. So now pay attention. What we are looking at right now are the methods that are really in the list class. I mean, originally, they are inside the list class. Inside this namespace, for example, there are extension methods inside certain static classes. Just imagine this namespace contains a few static classes with extension methods inside that extend the list class. Therefore, if I'm using this namespace, then suddenly, by using the same magic, this list of methods is extended with plenty of new methods. If you look here closely, you can see that certain methods have this arrow, downwards arrow in front. Actually, those are the extension methods. For example, this aggregate method. This is an extension method which is not original in the list class. This only extends the list class from outside. And if you check out the tooltip here, you can see that the word extension is written in front. So this is a real extension method. And all those are extension methods with the arrow in front. Yeah, so I just wanted to demonstrate you that extension methods are really used inside the .NET framework as well, and you can also use them. You can also create new extension methods. They can be used in a very nice, very convenient way. Do you like it?
Yes.
Okay, thanks for the feedback. Actually, believe or not, I love getting feedbacks, because right now it feels like I'm talking to my computer only. All of you are muted and nobody shares his or her webcam. This feels bad for me, but anyway. Okay, let's see what's the situation in other programming languages. I already mentioned this to you. Only C# provides extension methods. I mean, neither C++ nor Java nor Python provide those. You can simulate or emulate such extension methods in those languages by using helper classes. If you remember, helper classes are static classes, but they are not the same. Actually, you are not extending an existing type with a new method. So this is something much weaker. Great. I'm glad you liked extension methods. I hope you will like our last topic for today, abstract classes. I already mentioned to you that this topic is the most important among our today's topics. I also mentioned that probably you will learn about abstract classes in your practice class. I'm not sure. I'm not 100% sure about this, since your teacher in the exercise class is Mr. Kusper, as far as I know, and I'm not sure he will talk about abstract classes, or did we? Did he?
Yes, he.
Really?
Mostly. Yes.
Yes.
Wow. Great. Okay, this is really great. Yeah, abstract classes are actually important also because they, how to say, they introduce an even more important element in object-oriented programming, which is called an interface. Have you already learned about interfaces with Mr. Kusper?
No.
No?
No.
Okay. I think you said no. Okay, but you will pretty soon. And actually next time I will talk about interfaces, I mean next week in my lecture as well. Anyway, let me talk about abstract classes. So you already know what an abstract class means. Some parts are not implemented inside the class. And you know what happens if you have a class with non-implemented methods, then it means that the child classes will implement those methods. So currently they are not implemented, but it will be the duty of the child classes to implement those methods. If you didn't know the abstract keyword in C#, even then you could solve this problem. You could introduce virtual methods in the parent class with some dummy body, as you can see at the bottom. For example, you could throw an exception, sorry, if anyone calls this method, and this exception would tell the user that this method is not implemented yet. And this solution is okay, but this is not a nice solution, because this exception is thrown only in runtime during when you execute your program. It would be nice to see how to say, it would be nice to sense that a method is not ready during compilation time inside your Visual Studio. So therefore, in C#, and not only in C# actually, also in in Java, for example, they introduced a new keyword, a brand new keyword, abstract. You put this keyword in front of methods, and as you know, in this way, as you know, so you put the abstract keyword in front of methods. And there is another important thing here. You must not give a body for your method. You see here, I'm using a traditional method translate. This is not abstract, therefore I must put a body, give a body to my method. For abstract class, you must not give a body. Rather, you should use a semicolon at the end. So basically for abstract classes, you only specify the header of the method and not the body. Exactly. So let's continue with the second item here. If your class contains at least one abstract method, then you must mark your class, your entire class, as abstract, as you can see here. So since my shape class contains 2 abstract methods, I must mark my class as abstract. And this tells for all the programmers that, yeah, this class is not ready yet. You cannot use it for instantiation, for example. The child classes, for example, the circle class on the right-hand side, to the right-hand side, will implement all those abstract methods. Okay, this is written at the bottom here. Abstract methods must be overridden in child classes. And there is a last statement here, which I will explain a little bit later. So let's see this example again. You have an abstract class with 2 abstract methods. And you can see a child class. The child class must override all the abstract methods, which means the child class must give bodies to those methods. That's it. Yeah, I would like to draw your attention that in the shape class, I'm using 2 fields. For example, those 2 fields X and Y X and Y can represent the top left coordinate of my shape. And since all shapes have this top left corner, circles or rectangles or squares or whatever child class I'm going to implement later on. Therefore, I've put those 2 fields inside the shape class. Furthermore, as I already mentioned, I'm implemented a non-abstract, a traditional method here, translate. You know, translation means that you translate your shape in the screen by using some vector. So you translate your shape to the X direction and to the Y direction by a certain magnitude. Anyway, since this is a non-abstract method, I must implement it. For example, what translation means? I clear the original shape, I translate it to a new position, and I draw it. I redraw my shape. I can implement this method. This is why it is a non-abstract method. It is interesting though that inside this method I'm calling 2 abstract methods. Both the clear and the draw methods are abstract methods, but I can call them. I can call them because abstract methods are actually virtual methods as well. So since clear and draw are virtual methods, Therefore, when I'm going to call this translate method, the framework will automatically call the corresponding overridden version of those methods, because you know virtual methods use late binding. I hope you understand this. Okay. Okay, so abstract methods are actually virtual in disguise. This is why we need to use the override keyword when we override abstract methods. Okay, what else? Class level methods cannot be abstract. This is kind of logical. And since methods can be abstract, properties can as well. Here you can see an example. Inside the shape class, I introduce a perimeter property. I mark it as abstract, which means I must not implement the getter or the setter. In this case, I must not give a body to my getter. So therefore, I must close my getter with this semicolon. So this is how an abstract property looks like, what an abstract property looks like. Get semicolon, or you can also use set semicolon. Now I would like to use only a read-only property. This is why I use only the getter. Inside the child class, of course, again, I must override my property and implement. I must implement the body. I must implement the getter. So I must give a body to my getter. Do you have any question regarding this stuff?
No.
Are you sure? Yeah, you are. Okay, then. Okay, then I still have plenty of time. Let me go back to my previous slide, which was, yeah, here at the bottom. So I told you abstract, the child classes of abstract method must override, the child classes of abstract classes must override abstract methods. This is what you see here, and this is what you see here. It also holds for properties. But there is an exception, of course. If you have an abstract class and the child class is also abstract, which can happen, then of course this abstract child class, for this abstract child class, it's optional to override the abstract methods. Since the child class is also abstract, it could be not ready yet, right? So it can still contain abstract methods. And actually, this is typically the use case in real life in big software projects. You have an abstract class which has abstract child classes, and those abstract child classes can have also abstract child classes. And at some point, at some level of this class hierarchy, it will happen that an abstract class will have non-abstract child classes. Inside those non-abstract child classes, you must already override all the abstract methods and properties you inherited from all the parent classes. Yeah, so in real life, here it is written, in real life, in big software projects, typically, in the class hierarchy on the top, there are a bunch of abstract classes. And below those bunch of abstract classes, you can find your non-abstract classes. So this is very typical. And it makes sense because, you know, this is the idea of inheritance. Parent classes are always more abstract than the child classes. As you move downwards in the class hierarchy, your classes get more and more concrete, more and more less abstract. As you move upwards in the class hierarchy, your classes get more and more abstract, more and more high level, so to say. Therefore, again, in the class hierarchy on the top, you can typically find abstract classes, which cannot be instantiated, of course, since they are abstract. They serve only one purpose. They basically, you know, give common base classes for the derived classes, for the child classes. Yeah, so let me show you some real life examples here. And this is what I'm going to, how I'm going to close my lecture, basically. So let me show you, let me talk about those diagrams, those kind of diagrams. This is what we call a class diagram, and class diagrams are widely used in software projects. Actually, before a software project starts, I mean, you know, programmers implement the project itself. Someone, some architect draws some plans about this project. What classes, for example, what classes this project should consist of. So here you can see that my project consists of 3 classes. There is a very abstract class, the shape class. As you can read inside the text boxes, abstract classes and abstract methods are written in italic letters. So the shape class is abstract, and inside that class, the get area method is an abstract class. The abstract method, sorry. You can see the two child classes of the shape class below. That's another example. This is a much more real life example. Let's suppose you are working on a e-banking software, which could happen in your future job. So let's suppose here it makes sense to use an abstract parent class, bank account. For this bank account class, there is a method, the deposit method, that can be implemented already because it works. The deposit works the same for all kinds of accounts. But let's suppose the withdrawal method works in different ways. It works in a different way if you use a checking account or you use a savings account. Therefore, in the parent class, the withdrawal method is an abstract method. You cannot implement it yet, not in that class. You can implement this method only in the child classes. Okay. Let me show you another example. Do you have any idea what this example is about? What kind of software I'm trying to implement here?
Okay.
A game, yeah. A game? What kind of game? a chess game. You see here here are the pieces, the chess pieces, queen, king, knight, and the others. Anyway, look at this diagram. So could you tell me which classes are abstract? Which classes are abstract here? Which one?
Okay.
The game. This is what you told us?
A board.
No, not the board.
There.
You know, look for italic letters. Italic means, you know, this kind of letters.
Here.
So, which one?
Player.
Player, exactly. The player class and the piece class. Okay, look at the piece class. It makes sense because inside the piece class, you have also 4 abstract methods. And it really makes sense because, you know, in general, you cannot implement, for example, what are the valid moves for a piece or which squares a piece can attack. It depends on what piece we are talking about, a queen or a bishop or what. Therefore, in the parent class for the queen and king and knight and bishop and rook classes, I can only introduce those methods as abstract methods. I cannot implement those. I will implement all the 4 methods inside the respective tri-classes. Inside the queen class, I will implement those 4 methods as requested. In the king class, I will again implement those methods. You see? I hope you see the importance of abstract classes. I think this is a very nice example and it's easy to understand why abstract classes and abstract methods are really handy. Even when you plan, when you design your project before actually starting to code. Any question? No. Then 2 more slides left. About other languages, so here, let's see if those other languages provide abstract classes, abstract methods. I already mentioned that in Java, that Java provides the same. So in Java, you can use abstract methods, abstract classes. Of course, you cannot use abstract properties because in Java there are no properties. But apart from this, everything is the same in Java. In C++, oh, sorry, here is an English, a Hungarian sentence. Okay, so in C++, there are abstract classes, but there is no abstract keyword. You can see a piece of code in C++ here. So actually, if you have a class, now the base class, you can put abstract methods inside. In C++, and this is a very ugly syntax, this is how you can set a method as abstract. So you use this =0 ending. this tells the compiler that there is no body that assigned to this method. There is no content in the method actually. This is really, really ugly, but actually this is how you can, again, you can turn a method abstract. In C++, actually, these kinds of methods are called pure virtual methods, not abstract methods, but this is only play with words. Yeah, that's it. This is kind of interesting in C++. But the main message here is that both in Java and C++, there are abstract classes similar to C#. And actually in all the real OOP languages, there are abstract methods and abstract classes. Python is not really a real OOP language, and well, in fact, Python has no such thing as abstract class or abstract method. But as usual, Python provides an additional module which you can import, and by doing so, somehow you can introduce abstract methods, but this is only an extension and it's kind of ugly, and it doesn't belong to the core of Python. Yeah. Okay, that's it. 1 minute left, then Zoom will disconnect. So do you have any question at the end?
No, sir.
No, sir.
Are you sure?
Pretty sure.
Okay, then I shared the slideshow with you in the e-learning site. Excuse me?
I have one question. Have you had the code today?
Do you need the code as well, or what?
No, did you do the code today?
I don't understand. Sorry.
Did you do Kahoot today? He was asking.
Yes.
What?
The code.
Kahoot.
Kahoot did.
Kahoot,
Yeah.
yeah. There was a Kahoot quiz. And what? Yeah. Okay, so see you guys next week then. Have a nice